Alright, in the last video you saw the derivative of inverse trig functions, right? What we saw is the derivative of sine inverse x or arcsine x is 1 over under the root 1 minus x squared. So since the antiderivative is just the inverse process of the derivative, just the integral of this part is sine inverse x, right? Similarly, you see that if there is a sine inverse and some function of x, not just x, if it's just x, then it is 1 over 1 minus x squared. But if there is like x squared, x cubed, x plus 3, x plus 5, like that, then this is like sine inverse u, right? So the derivative of sine inverse u with respect to x is 1 over under the root 1 minus u squared times u prime. Okay? So that's the derivative. So thus, under the root that thing, 1 over under the root 1 minus u squared times u prime dx is sine inverse u plus c. Similarly, the derivative of tangent inverse x. Tangent inverse x is 1 over 1 plus x squared. And then, so thus the integral of 1 over 1 plus x squared is... Thus, the integral of 1 over 1 plus x squared dx, that's just the integral of 1 over 1 plus x squared, is tangent inverse x plus c. So similarly, you see that instead of x, there is some u function of x. Then where u is a function of x, that u may have x squared 1 plus x squared, like anything, right? So if there is tangent inverse u, then the derivative is 1 over 1 plus u squared times u prime. Thus, integral of u prime over 1 plus u squared dx is tangent inverse u plus c. Okay. Similarly, for the secant inverse u, the derivative is 1 over absolute value of u, and then under the root u squared minus 1. You see, there is 1 minus u squared, there is u squared minus 1. You should be careful. If there is u squared minus 1 format, then you need to write in terms of the secant inverse, right? So thus the integral of 1 over absolute value of u under the root u squared minus 1 du is equals to, oh, by the way, I forgot u prime as well. Du is equals to secant inverse u plus c, because the integral of this quantity is secant inverse u plus c. Okay, so we'll use this formula. Okay, we'll use this formula to find the integral. Okay, guys. All right. The first one is let's see some examples. First example is example number 4. Okay. In example number 4, we have 1 minus something square format. So it should be sine inverse. But sine inverse need integral of 1 over 1 minus u squared. That quantity needs square of something. And then times u prime. So you need times u prime there. So you set, oh, let me use different color for that. So let us do set 2x equals to u. Okay, if you do 2x equals to u, I want to keep, you can think, I should not say set. So I should not say like this. What I want to do is I want to write like this, okay? Because I'm not using the substitution method here. I'm just using a shortcut. So I want to write something square and the derivative of that thing. So what I want to do is I want to write like this. 1 over 1 minus 2x square dx is like under the root, right? It is like 1 minus u squared. But what is the derivative of 2x is 2. But we need 2 on the top, right? You see that? 1 over root under 1 minus u squared. You have that formula. But you need u prime, that is 2. So what I'm going to do here is I'm going to multiply by 2 and then divide by 2. So if I do that, then what do I get? I get this is equals to 1/2 integral 2 over under the root 1 minus 2x square and then dx. Look at that. It is like u prime over under the root 1 minus u square. U prime over under the root 1 minus u square dx. So this is like 1/2, and then you can write sine inverse 2x and then plus c. That's what you can write here. You see that? Okay. All right. So how about this one? How about this one? By the way, one thing that I wanted to mention is, suppose instead of 1, suppose there is, let's say, 9. If there was 9, how would you do that? If there was 9 here, 9 minus 4x, so it is like 1 minus u squared format, but there is no 1. So what I need to do in that case, I would do like this. I would take 9 out first. If I take 9 out, how would that look like? It is like, this is how you can take 9 out, right? You have like 9 minus 4x squared, right? So if I take 9 out to make 1 minus 4/9 x squared, right? You would do like that. And take that out will be 3, and under the root 1 minus 2 over 3x squared. Did you see that? It is like 1 minus u squared form. You would do that way. If there was, instead of 1, if there was 9, you would do like that, and then you use the formula, the same technique that I just used. Okay, that would be the case if it was different from 1. Okay, guys. All right. So we'll do some more example later related to that, like example number 8. We'll do that, but for now, just think that way. Okay, guys. All right. So the next thing is, let's do this one. Since there is a plus, it is like tangent inverse, right? So you need to do 1 over u squared. So can I write like this? Can I write like, let me write the integral. I can put 12 here. Okay. I can put 12 here, or just let me keep 12 inside for now. And then write 1 plus, you can write 3x squared, right? And then dx. It is like 1 plus u squared, 1 plus u squared. But you need the derivative. What is the derivative of 3x? It is 3. You need 3 on the top. So what I'm going to do is I'm putting the 4 outside and then write 3. For 12, we're going to write 4 times 3, right? 1 plus 3x squared dx. Now, you see, there is a function 1 plus u squared, and then u prime is in the numerator here. U prime is in the numerator here. 1 plus u squared, and then u prime in the numerator, okay? Dx. So what is that? That is 4 tangent inverse, and then 3x plus c. That is the final answer. Okay? So you need to put in that format, and then you need to know that what should I take for u. We are not doing u substitution, but we are trying to change in the formula of u here. It is not a u substitution because there is still dx. Okay, there is still dx. We are not doing u substitution. We are just thinking like that. If I take this as u, how would that look like, kind of, okay? So here, look at this. It is like 4 plus 3 minus x squared. It will be like definitely u, but there is 4 as well. So I need to take 4 out, okay? So how do I do that? I'm going to do this way. So what I'm going is, I'm taking just 7 outside and then doing 1 over, what I want to do is, let me take 4 out, and then I can add 1 plus 3 minus x squared divided by 4, and then dx. You see that? 1 plus u squared is there, but that denominator is not in the u squared. So what I'm going to do is 7 over 4, I'm just pulling that out, okay? And then integral 1 over 1 plus 3 minus x over 2 square. It is like 1 over u square, right? Dx. But what is the derivative of that? The derivative of that is negative 1/2, right? Because you see that? This is like u square. What is the derivative of u? You need the u prime on the numerator for that, right? U prime in the numerator. That's u square. But the derivative of u is u prime. That is negative 1. So I need negative 1/2 here. What I'm going to do is, I'm multiplying by negative 1/2 and then dividing by negative 1/2. Negative 1/2. Like that. So what do you get? This is multiplying by negative 1/2. Okay. So what do you get there? You will get, because you divide that by, so it is like negative 7/2, right? Because 4 divided by 2, 1/2 times 4. And integral of a negative 1/2, that is u prime 1 plus 3 minus x over 2 square dx. It is like u prime over 1 plus u square. So what is that integral? Negative 7/2, and then you can do tangent inverse, right? It is tangent inverse that u, that is 3 minus x over 2 and then plus c. That's what you can do. Okay, that is the final answer. Let us do this question number 10 from your book. You see that there is one thing outside like this one. Since there is something outside, then you should think like this is secant inverse, okay? But there is x to the fourth. Secant inverse doesn't have formula that has fourth, so you need to write in terms of square. So how can you write that? So you can write this as, you can write integral 1 over x under the root. You can write x squared to the square minus 4. But we need negative 1 though. I need to take 4 out. If I take 4 out, what will happen? Look at this. If I take 4 out here, okay, so that will look like, let me take 4 out from here, okay. Let me go back a little bit and then I will do that first. Let me take 4 out from here. If you have like x to the 4 minus 4, okay, then you can take 4 out as like this. So 4 out, you can write x squared over 4 minus 1, right? If you simplify, you will get the same thing if you distribute. So take 2 outside and then do x over 2. Oh, by the way, there is x to the fourth. X to the fourth over 2. You see that? X to the fourth over, I would write x to the fourth over 4 minus 1. You see that? X to the fourth over 4 minus 1. If I take 2 out, okay? So what I'm going to do here is 1/2, that is that 2 thing, okay? And then let me remove that first. Let me remove this one. Okay, so I'm taking 1/2 out and then I'm writing this as x to the 4 over 4 minus 1. That's what I'm doing, okay? I took 4 out and then simplify that way. Now again, so it is like x to the 4. We need u squared minus 1. So what I'm going to do here is I'll think like this. 1/2 and then integral 1 over x, okay? And then under the root x squared to the x squared over 2 to the square. You see that? Isn't that x to the 4 over 4 minus 1? And then you can think like, what is the derivative of x squared over 2? It is, so what is the derivative of x squared over 2? It is x, right? So you need x here. You need x here. Because the derivative of x squared over 2 is 2x over 2, that is x. So you need x here. But how do I do x? What I am going to do is I'm multiplying by x here and then dividing by x. So it is like that, right? So what do you get? You get basically, you get 1/2, because you know that we need u prime over absolute value of u and then root under u squared minus 1. So what I'm going to do here is I'm going to write x over x squared, okay, and under the root x squared over 2 square minus 1. You see that? But you see that whatever here, look at this, u is square, but you need u here. So you need x squared over 2 here. So what I can do for that is I can do over 2 and then times 2 and then multiply that 2 with the 4, right? And then we'll have exactly the format of the formula. So you can write this as, and then dx is there. You can write this as 1 over 4 because that is 2 times 2. And integral x over x squared over 2. You can write absolute value or you don't need because it is a positive. And then under the root u times u squared minus 1. You can think that way. So it is basically, the final answer is 1/4. It is secant inverse x squared over 2, okay, and then plus c. That's what you get. So secant inverse x squared over 2, okay, and then 1/4 is there already, plus c. That was question number 10. How about question number 12? You see that this is like a u, right? So what is the derivative of u here? The derivative of u is, this is like natural log. What is the derivative of natural log? Because you know that natural log of x prime is equals to 1 over x, right? So this is in the nice format already. You can write 1 over x, that x you can write there, and then divide by under the root 1 minus natural log of x square, right? So it is u prime over 1 minus u square dx. It is 1 minus the 1 minus u square and then u prime in the top. So it will be sine inverse. Let me write down here. Not on the top. So it is like sine inverse natural log of x plus c. Okay, guys. So this is how we find out the integral of some of these basic examples. So in the next video, I will present you more examples of this type. Okay, guys. All right. Thank you.